Okay, so extra help is going to be given Friday morning starting at 7:15, and my hope is that everybody has an opportunity to log onto this blog site here and take a look at the solutions for each one of these questions before coming to extra help. And then so tomorrow morning when I see you, if you still have any issues with these or not quite sure exactly what to do or how to do it, by all means come in and see us tomorrow morning at 7:15. Here are the answers, though, to the review sheet that you guys started in class. The two quantities being compared are going to be obviously your miles to minutes. And we have to find the unit rate per mile for each runner. On the original sheet, this idea of per mile was omitted. It was left out, and we have since added it in class. That I'm asking you to find the unit rate for miles, not for minutes. It's actually going to make things a lot easier, as you'll see. We're going to use TRF for all of this. So our template is going to be miles over minutes. We'll do Anthony first. If we look on the data table, for Anthony, we have 5 miles in 30 minutes. And we are trying to find the unit rate for miles, so 1 is going to be at the top. And we have to take a look at what our division factor is to figure out the bottom. We're dividing by 5. And if you do that, you're going to wind up with 6. So Anthony's unit rate is 6 minutes per mile. That's just saying that he can run in his 1 mile. It will take him 6 minutes to run his mile. Now for Ken, miles over minutes. And Ken is going to be 7 to 63. And when we do the division factor, it's divided by 7. And that's going to give you 1 to 9. So his mile takes 9 minutes. Okay, Kira, same thing, miles over minutes. And she is 2 to 30. A division factor of 2. And that's going to give her a 15-minute mile. Finally, Michelle. Miles over minutes. And again, we're getting this from the data table up top. That's a 3 to 36 ratio. Division factor of 3. And that's a 12-minute mile. So after you've done this, you get a sense of who the quickest runner is. And that would be Anthony. And the slowest would be Kira. Now, in order to do number 2, or page 2, question 3, this was also added after the dittos went to copy, that you had to use the information from number 2 for Anthony to figure out how to do this next question. So here's how we proceed. This was a tough question. You had to incorporate a lot of different detail, or a lot of different pieces of data in order to do this. We're going to use TRF because TRF is always a good starting block for a lot of this. Not a whole lot of room to work here, but we'll squeeze it in. Miles over minutes, that hasn't changed. We're just taking that from our original example. We're going to take Anthony's unit rate. So if you go back and find Anthony's unit rate, He was a 1 to 6, 1 mile in 6 minutes. We need that piece of information in order to figure out this question. So our given ratio is 1 mile in 6 minutes. Now if we go back and take a look at the question, he's planning on entering a half marathon. That's a VIP. And it's 13 miles. We're not going to worry about how old he is yet. We've got to figure out how long it's going to take for him to run 13 miles. That becomes the second equivalent ratio. 13 miles over what we are trying to find his time for that. We have a multiplication factor of 13. So we've got to do that to 6. And after you've done that, you'll find out that this is 78. And that's minutes. Now we can go back and revisit the question and see how old he is. He's 46 years old. Now we've got to take a look at the chart, find the age range that includes 46. That's this right here. And in order for him to qualify and to enter, he has to be able to complete his 13 miles in 85 minutes or less. And since 78 minutes is less than 85, yes, he's able to enter. And you would explain why. I'm not going to write it here because of time, but you want to explain that 78 minutes is well under his 85-minute maximum, or the 85-minute maximum that's required, so he would be able to enter. Okay, we move on to the next one. The ratio of dollars to pounds is 0.8 to 1. Now what I've noticed is some students are getting hung up on the word dollars. If I had said cost to pounds, they would realize 80 cents or 0.80 to 1 might have been a little bit more apparent. I think that word dollar winds up being somewhat of a stumbling block for you, but dollars in this case means cents. And so our ratio is 80 cents or 0.8 to 1. We wound up crossing out B because of time and because of the fact that you have to divide with decimals and you got to move over a decimal to get an accurate reading. Some kids have been able to do this with equivalency ratio tables, but we just skipped it all together because, again, we were a little short on time. We got to the bottom, which we can do, and it's the same thing. We're going to set up a TRF, and in our TRF, we'll do it the way it reads: dollars to pounds or cost to pounds. We take our original ratio, which is 0.8, which is 80 cents per pound, and then we've got to determine what the cost is, how much, and I've told you guys and I've told students, look for keywords: how much, how little, how big, how small. In this case, how much, because that's going to lead to what we're trying to find. How much will it cost indicates we're trying to find cost. And they give us the second part of the ratio, which is 7 pounds, and pounds is on the bottom. So we have everything now set up. This is going to create a multiplication factor of 7. And then when you do 0.8 times 7, you get a monetary value of 5.6, which is $5.60. And that's our answer. Some of you are still having some difficulties understanding how to multiply with decimals, especially when it comes dealing with money. Okay, moving on to number 5. TRF again is going to be minutes over ounces. And they tell us that 3 minutes is every 3 minutes runners should drink 1 ounce of water. So that's a 3-to-1 ratio. If they continue at that rate, how many minutes? There's our keyword of what we're trying to find. To drink 8 ounces. Multiplication factor of 8. And that's going to be 24 ounces of water. I'm sorry, 24 minutes for 8 ounces of water. Okay, in 19, when we did 19, we explained that when you see an equation, that is also our unit rate. So when I set this up, miles over minutes, this equation is telling us 1 mile is going to take 7 minutes. When we do the other runner, we actually have to read the data table, go to the coordinate point for 1 mile, and then read across, and that mile to minute ratio is 1 to 8. So for John, just restating and summarizing what we determined up above, that John is going to run 1 mile in 7 minutes. And Sanjeev is going to run 1 mile in 8 minutes. The newest member is going to be the quickest runner. So that's the person that's going to run, essentially the runner that's going to run quicker. And that would be John. So he can do his mile in 1 minute less than Sanjeev. And I would do that in the explanation. I'm not going to do it here just because of time, but you would write out that it would be John because he is 1 minute faster per mile than Sanjeev. The review packet goes from 7 to 9. There's no number 8, which is okay. Just got numbered incorrectly. With this one, I saw this done 2 different ways. If we did not have to worry about unit rates in B, then the easier way to do this is simply double the 12 pack of water to make 288. And then you can compare the ratios. 288 is more expensive than 264, so Stop and Shop would be the better deal. However, since we have to compare unit prices down here, I'm going to go ahead and find the unit price for each bottle of water at each store. So we'll start off with Stop and Shop. Set up a template, bottles over cost. Stop and Shop, we're going to have 24 for 264. And we have to find the cost of 1. You have to divide by 24. That's going to result in a dollar figure less than $1. So the way you set this up is 24 has to be outside the house and 264 has to be in. And it will work determination, and it winds up being 11 cents for Stop and Shop. For Wall Bombs, same template, but this time it's 12 over 144. Got to find the cost for 1. Division factor of 12. And this will also go to termination as 12 cents per bottle. Better deal is going to be Stop and Shop. And the difference between the 2 unit prices, it's not much, but it's only a 1 cent difference per bottle. but every penny counts. Okay, number 11. TRF again. Set up our template as yards over miles. They give us the conversion rate, and you will be given conversion rates tomorrow on the test, so you don't have to memorize any of this. 1,760 yards per mile. Whenever you see per mile, we're talking about per single mile, per one. And we've got to figure out how many yards in 5 miles. We multiply by 5. Same thing to the top. And you get 8,800. And that's yards. We wound up crossing out 12 and 13 because we did not do formulas. No big deal, because we can do it with TRF anyway. We do 14. Set up your template again. Miles over hours. That's going to create 5 over 1 as our given ratio. And we have to figure out how far 3 hours multiplied by 3. You get 15. For number 15, same thing. Miles over hours. Use TRF again. 12 in 3. Equals 1. How fast does he run per hour is what we're trying to find. It doesn't say that, but that's what we're trying to do. Divide by 3. And that's 4 miles in 1 hour. Or 4 miles per hour. And finally, here's the last one. We need to see who's running at a faster rate, so we're really talking about 2 TRFs. I think the easier way to do this is putting miles on top over minutes and finding the unit rate per mile like we've been doing. If you reverse it and find the unit rate per minute, it'll still work, but you wind up dealing with decimals. So we'll keep it where we're trying to find the unit rate per mile. Ken is 2 miles, 18 minutes. That's going to create an equivalent ratio when we divide by 2. 1 to 9. That's Ken. Anthony. I'm assuming it's the same Anthony from problem 1 because, as you'll see, his mile to minute ratio is exactly the same as it was in the first problem. But let's just be sure. Division factor of 5. And sure enough, we do get 1 to 6. Who's running at a faster rate? Obviously Anthony, because he can run his mile in quicker time. And that's that. Now tomorrow, when you guys take your test, you have to show a strategy. You'll see on some questions tomorrow, they will tell you to use TRF. If they tell you to use TRF, use TRF. Other parts of the test will tell you to use any strategy, which means equivalency ratio table, tape diagrams, rainbow diagrams if you want, double line diagrams if you want, but any strategy that I've shown you in class has to be shown on the test. Okay? We can't just multiply two numbers together, even though I know that you know it in your head. If you choose to use TRF, I've got to see a template, I've got to see a ratio, and I've got to see what it is you're trying to find. Okay? Each part of that process is worth points. So if a question is worth 10 points, you get, for instance, if this was worth 10 points, you get 2 points for that. You get 2 points for this. You get 2 points for this. And then let's say you do the calculations correctly. Your math is correct. 2 points for the correct math. And let's say 2 points for a sentence. And that's your 10 points. So there is lots of opportunities for partial credit. If you choose not to do anything and leave it completely blank, you're throwing away a lot of points. So make sure if you still are not sure how to solve it, at least write down what you do know. Create the template. Create the given ratio, because every time you write something down, you're going to get points for it. And you don't want to just throw off 10 points for not doing anything. And again, if you still have some issues with this, I'm available tomorrow morning. The doors open at 7:15. Come on down and ask any questions that you might have. Otherwise, I'll see you tomorrow.